Boy, that's a neat way to travel. Isn't it great?
But everyone was waiting for the big engine. The XLR99, a brute that would blast out nearly 60,000 pounds of thrust to drive the plane to peak speeds and altitudes. This engine is installed in the third and last plane of the series, which has always been slated to be the test bed for this new power plant. And Crossfield uses his time in between flights to ring out the installation. Preliminaries are out of the way, and this run will be one of the final before flight. This long-awaited engine can be throttled, having an idle output of 30,000 pounds, but able to be regulated between idle and 60,000 pounds of thrust. Today's runs are the climax of a long series of tests proving the installation. After this start, they're ready for flight.
Valve malfunction. Throttle off. Reset.
In a split second, years of planning, months of test and grinding work went up in smoke. There was only one real observer, one eyewitness, the pilot, Scott Crossfield. Scott, what was your immediate reaction?
Well, it was the biggest bang that I'd ever heard. Fortunately for me and the airplane, the explosion blew the forward section, the tanks, and the cockpit out of the blaze, or out of the major part of the blaze. And the firemen were right on their toes, and they moved in to blanket the tanks and the fire area with foam. The first reaction we had was that the engine had blown up, but like many first impressions, this was wrong. As soon as the parts cooled down, a disenchanted group of engineers moved in, and as you might imagine, things were pretty well scattered about. We also took a close look at the film that you've just seen, and here are a couple of frames that gave us our first clue. Just before the blow-up, a cloud of vapor appeared ahead of the engine. So the search was concentrated on this area. Following up this lead, we found that the hydrogen peroxide tank had been rammed, smashed open. But with what? Lining up with the tank is the center structure of the ammonia tank, and its shape matched the impacted area of the hydrogen peroxide sphere. But how could this part fail? Likely through overpressure. Now, a check of the instrumentation showed tank pressures far over normal. Again, the question, why? The pressure regulator was recovered and checked. It was determined that freezing caused by the very low temperature pressurizing gas had caused the regulator to stick full open. But there's a safety, a valve to relieve overpressure. This valve and the entire release system was also checked. Here it was determined that a flow-sensitive relief valve combined with a vapor disposal equipment had created enough back pressure to fail the tank. So, a frozen regulator, a faulty relief valve, and a high back pressure relief system had gotten together, and we had wrecked an airplane. The entire pressurizing and release systems were analyzed, redesigned, tested, and retested. We ran the combination time after time, deliberately creating the most severe failures possible. Weeks passed before we and everyone else were convinced that the problem was licked.